G'day. You saw in the last couple of videos I set up my Scamp Lite. I put a IoT device in there to keep track of things like temperature, battery level, various IoT things that I wanted, which is okay. I can go online and look at that information. It only just shows me once every hour, so it's a bit behind the scenes. So I thought I wanted to put a real-time OLED display in the Scamp as well, so I could just push a button and see what the current battery level is and current temperature and things. So this is my quick bit of CAD using the Dave CAD type system. So just one little plastic box. I'll probably 3D print that, and a couple of buttons, one to get the power information, one to get the climate information, and have that tie back into my original IoT box through a I2c connection. To do this, I decided to use one of these Raspberry Pi Pico development boards. I hadn't seen one of these before, but this is quite handy. It gives you a little breadboard, and I can put my Raspberry Pi Pico on there. And what I needed to do was try out a couple of devices. So I needed to check that I could connect up a OLED. Also wanted to be able to use different font size on the OLED, and the other thing I wanted to do was check out that I could use I2c to get the button statuses. I didn't want to run wires from the inside the device. I wanted to keep to I2c, so this board allowed me to do that as well. So I used a couple of libraries to run the OLED and also run the interface to the buttons. So first, for running the OLED, I wanted one that could display fonts in different sizes. The default interface to the OLED display only shows fonts in 8x8 characters, which are a bit small for what I wanted to do. I wanted to show the main measurements in a big font so you could see it easily, like number of volts, what the current temperature is and things. And then just small fonts for showing some information about, like text about what I'm actually displaying. To do this, I'm using Peter Hitch's Micropython font to Pi library. It's out in GitHub. I've used this before for the Bayes calculator as well. It actually has two capabilities that are built into this GitHub repository. One is to, let's go to the README. And it has really good documentation as well. One is to create the actual font files that you're going to use when you display fonts. There's some basic ones that come with it, but you can create more fonts files, and basically he gives us a utility where we can read a font file, say what size you want it to, and it'll create a Python file that has that font file in it, so you can cut down both what you want to include in that font file, because they use up some space on your microprocessor. So you may only want numbers, which is one of the font files that I use, which is just numbers, no alpha characters, made it a lot smaller. And you can use different font files as well. So I didn't actually use this for this project. I already created all the font files that I needed when I was doing the Bayes calculator, so I just used the font files that I'd created in there, but there's a good description of how to create font files here. And then the piece I did use was this writer component, and he's included some font files in there and a demo of how to use that writer component. And I'll show you the code that I used to put together the display that I wanted for my actual Scamp IOT display. The other library I used is this one for PCF8574. PCF8574 is one of these things down here. It's a little board. It has a I2c interface and provides 16 lines of input or output, so you can my case, I can use them to sense whether a button's been pressed and send the information back through the I2c interface, which saves me a couple of wires rather than running wires directly off a I/O pin on the Raspberry Pi Pico. So this is the library I used. It's from Micropython. So here's the example code I used to test out those two libraries, make sure I can write through the OLED in different font sizes and detect a button being pressed all through I2c. And this library's out of my GitHub repository, so I'll include the link down in the description. So basically I'm importing FreeSAN num35, so this is fonts to write out numbers at 35 pixel size. I import machine, the PCF8574 library, and time. So just as per normal, I set up an I2c interface in Micropython, set some OLED details, set up the OLED object, just the normal way you would with a SSD1306 OLED. Create an object for the PCF8574 item, and then I set up this little loop. It's really just I wanted it to loop 70 times. I sleep 0.2 seconds between each loop, and this is really just to detect that I'm pressing one of the buttons on the PCF8574 device pins, and show a big number in the OLED display. So it just runs around looking for if I'm pressing the button and changes the display from a big 0 to a big 1, or big 1 to a big 0. So that's where I set up which pin I'm watching. And here's where I write out the display. And I'm actually doing two font sizes, so one just using the default font of 8-bit font at the top, displaying where I am in the loop from N 0 to 70, and then draw a line, and then below that I'm writing a large number just indicating whether I'm pressing the button or not. One other thing I'm doing is I'm displaying I'm setting an output pin as well, and setting a LED based on that. So let's have a look at this running. So I'll show this running on my breadboard kit. Let's run it. Sorry, the board's upside down in the display, but you can see here when I don't press the button it shows 1, when I press the button it shows 0. Also you can see the LED being lit up and turned off depending on whether I press the button or not. Okay, now I got the code, or the basic code to get it working. I need to move it back into my IoT Pico project. So these are routines I made based on that code, so kind of working from the bottom here, and I just put them in as callable functions in the main loop program of my main program. So I've got one for showing OLED power information, so that's going to show the amps and volts and the watts being used, and another one to show climate information on the OLED, so it's going to show the climate in Fahrenheit and humidity. These make use of a couple of other functions. So I've got this general routine OLED display value, so I can pass it a name, so the name of the thing I'm displaying, so something like volts, and then the value that I want to show, which is shown in large characters. And then I had one more little utility function in here just to center characters on the OLED. So let's have a quick look at show OLED power. So when this gets called, it gets the stats from the statistics counter for volts and amps. So first it checks that it has some stats in there, that it's at least got one sample already to display. Then I round it off and show that as amps, and then I call the OLED display value to show the amps, and I do a little bit of conditional stuff in here to decide whether I'm going to show or the number of digits I'm going to show for the amps, depending on whether it's milliamps or full amps I'm showing. Same thing for volts. It's going to go out to the stat volts, which is the samples for the voltage that I'm collecting, and show that on the screen, and then finally calculate the watts based on the volts and the amps concerned and show that. And I did add one more function into my stats. Just show you here, into my statistic object, to be able to collect the last value. So that's what it's collecting here in the main loop. When it's getting the values, it's getting the last value of amps and getting the last value of volts to display. So it's the most recent one. So it's not showing the average over the hour. It's showing just the last number it saw, which is kind of what I want. Same thing for climate. I'm getting the Celsius value and multiplying it out to convert it to Fahrenheit. So it's just getting what the current Fahrenheit value is, what the current humidity is. And down here in the main loop is kind of where you see these new functions being used. So remember, the main loop's going round and round and checking what's happening, whether a certain time trigger is met. So before, this was mainly just checking every hour whether it needed to send out IoT information through LTE. But now I've also got it checking, and it's actually looping every half second now. It goes and checks those buttons on the PCF8574. If I've pressed the button, so in here, if I press the button, that indicates I want to see the power information. So that's where it's calling that show OLED power routine we just looked at. Same sort of thing if I press the button to want to see climate information, then it'll call that routine. I've got some exception catching in there. So just looking at the Fusion 360 designs I use for the case. So the top of the case is shown here, so you can see it, what it generally looks like. And this holds the board that has the OLED and the PCF8574 device on it, and also a couple of buttons. So here are the holes where the buttons sit, and then in the middle is the hole for the OLED. I printed this about 5 times to get everything in the right place, but eventually got it all lined up. And as you can see out the side, I have a little hole for the cable that goes back to the I2c interface on my base unit. That also had a base, so this is what the base looked like. Nothing too exciting here, it just has a squeeze fit into the top. And then I also printed out some little buttons that go into those holes in the front, so you can see what it looks like. So it pokes out of the case, and then underneath it just sits on top of a button and stays fixed there because it's being fitted into the case in alignment with the button. But see that little hole underneath. So this just shows me assembling the pieces I 3D printed, and then the OLED and the buttons that I'd mounted on a little PC board so far. So those are the buttons. They fit over the top of the actual micro buttons on the board. So I just fit them into the case. They fit nicely in those little square holes there. The OLED aligns with the hole in the front as well. So that's kind of what it looks like, and I can press the buttons. It gives you a nice little click there. That seemed to work okay. And then the other piece was the PCJ8574. So I just mounted that on the back of the board I was using. So that all fits in the case. So I'll just show you what it looks like inside the Scamp camper. So let's have a look at how this gets mounted in the Scamp. So this is the whole case put together with the buttons on it, the OLED. And I put a piece of Velcro on the back, makes it really easy to stick to the what they call rat fur on the Scamp camper. And there's the I2c connector on the end. So first I stick it to the wall, and there's enough of a gap with the unit under the bunks that I can squeeze the wire down between that. And you see here underneath, this is where it connects into the I2c connector on my IoT box. So it just becomes another IoT piece of hardware, and I turn it on and it should detect it and start doing its IoT thing. So there's a demo of it running. So I press down the volts and amp button. So at the moment I'm pulling 0.9 amps. 12.55 volts on the battery, and tells me the total watts that I'm pulling down at the moment. So that's with 2 or 3 lights running in the Scamp. And then the other button is just the climate information. So same sort of idea, shows me the current Fahrenheit, 56, and the current humidity inside the Scamp. Those are about the only things I wanted to expose. So that's good. Looks like everything's working there. And this is what it looks like inside the actual trailer. So I got it next to the wall, mounted just above the bunk, because that's where I'm normally sleeping in it. So it's easy to get to and push the button and get a quick look at the power usage and the climate. Now this should have been the end of the video. Found I had some problems with my IoT logic. It wasn't really as reliable as I wanted. So let me just go through some of the things I did to fix that up, and just to let you know, I've been running it for about 14 days now with all the modifications, and seems very reliable. I haven't needed to reboot or go out to the camper. I can just track things remotely. But let's look at some of the problems I had. Okay, first problem I was having was with Wi-Fi not always connecting. And this is even when it's sitting in my driveway where I've got lots of Wi-Fi connections around, but it didn't seem to always connect. And we can see this in the IoT data. So the IoT data is information I see in back from the camper about kind of IoT status, kind of the technical side of things, and I use it for debugging a lot of time. So I'm looking at data from the last 60 days ago. And kind of beginning of November, you see this file sent, shows you how many files or sets of IoT data was sent each hour over LTE. And normally it's 4, which is the number of piece of IoT data I normally send. If it can't do an LTE connection, then it drops down to using Wi-Fi to try and send the data. So if we just roll down through here, we see LTE's going okay here for about a month. And then you see here, it lost its LTE connection and wasn't able to connect again. And I'll get into that later on about problems with LTE. But you see here, it should be sending the files over Wi-Fi when it can't get an LTE connection. And it's just not making a Wi-Fi connection as well for a while. You see it start to make it here. And see here, it actually sent 265 files to make up for all the missed file sent over Wi-Fi, but there was a big break there. LTE started working again, but it's kind of intermittent Wi-Fi, especially. I found it in this section here, so let's have a look at what I did to fix that. So this is the logic I had in the IoT Wi-Fi library for connecting to Wi-Fi, and basically it just had one option for connecting to Wi-Fi. So I'd go into the settings JSON file, find out what the SSID and password is for the Wi-Fi it should connect to, and tries to connect to it. If it doesn't connect to that particular Wi-Fi endpoint, then it fails and drops through. Okay, this shows the changes I made to the IoT Wi-Fi connect logic. So in here now it goes through a loop 5 times, or up to 5 times, and tries to connect with different SSIDs and passwords. So I have up to 5 sets of those Wi-Fi endpoints in my settings file now, settings JSON file, and it'll keep dropping through the 5 of them until either there's no more to connect to, or it has a successful connection, and it returns the SSID that it successfully connects to. So this is after I made that change to the code, and looking at the IoT data again. So the columns that are important here, this is the number of files sent over LTE, this is the number of files sent over Wi-Fi, and I added another parameter to keep track of it, is the SSID that it happened to use, or the index of the SSID it happened to use. So you can see here it's not always using the first one. So when it does get an LTE connection, it doesn't use Wi-Fi, so it just gives me a -1, indicating it didn't even try and use Wi-Fi in that case. Things were successful over LTE. There's a gap here, and then next time it connected, and this time it connected through Wi-Fi, it sent 20 files, so it was making up for all the hours that it didn't send any data. And it used SSID index of 2, so the second one. So there's the Wi-Fi connection it could get to. Next few hours, it just used the first Wi-Fi connection. So you see here, it was successful using the first Wi-Fi connection. So maybe the RV had moved, or I'd moved the Wi-Fi somehow. And then this one, it actually used the third connection. And same sort of thing here, use third for a while, then back to the first one. So having the option to drop through and seen up to 5 different access points made it more reliable for Wi-Fi anyway. If it didn't successfully connect to the first Wi-Fi connection, it could go to the next and the next and the next. And in most cases, one of them will connect and it gets its data returned that way. Okay, next problem I had was with keeping an reliable LTE connection. So most of the time, every hour, it wakes up and just sends via LTE the 4 IoT files that it needs to send, and that can run happily for days and days. But you can see you have things like this, and let's run down here a bit. Okay, so down here you can see it's not sending any files through LTE, and it's just sort of dropped out for, in this case, days. So there's the next problem I had to solve, was how to make sure it keeps connecting through LTE. Now, I'm not kidding when this behavior kind of drove me up the wall for a while. It took a long time to work it out, mainly just because this LTE connection process can be fairly slow. So in the end, I made this code here, this LTE reconnect, just to test out when I couldn't connect to or register an LTE connection with a provider, and then I would try and just do it over and over again until it did, and see if that worked. So that ended up solving the problem. I don't know whether that's the prettiest way of doing it, but seemed if I kept trying to register over and over again with an LTE provider, eventually after an hour or two it would connect and everything would be fine after that. I don't know whether it downloads some sort of time token or something, where after that it can just use that token to connect to the same provider, but it seems very reliable after it's been able to make a connection. Just getting that first connection or re-registration can seem to take a long time. So I worked out using this code that if I just banged away, kept doing LTE connects, and each one of these LTE connects time out after about 5 minutes. So if we go through 100 times here, it's taking quite amount of time to sit there just trying to register, but it eventually seems to work when there seems to be no other way to get LTE working again. So that gave me a clue, at least a way to, if I'm losing a LTE connection, get it re-established. Okay, this is a summary of the new code to allow us to do LTE reconnects. So you can find out more about main loop Pi routine in the previous videos I did. This is the main piece of code that gets performed every time in the RV IoT program. So it drops through after a restart, and first it goes out and checks whether there's a file called do LTE connect present. If it is, then it sets this wait for LTE flag to true, otherwise it's set to false. If it's set to true, then it's going to later on it's going to check that flag, and up to 50 times we'll try and do a re-registration with the cellular provider for that LTE connection. So that usually gets you through a stuck LTE connection. And remember, this is only done once after a restart, so it's not doing this all the time. It just does it once and only does it if this LTE connect flag is there. So the other part of it is the main event loop. So this is done continuously. It actually runs through this loop every half second or so. And among other things, it's going to check whether it's 1:20 AM, whether that feature flag to do a daily reboot is true. If so, it's going to reboot the machine. So this is how we get back down here to check for needing to do an LTE connect. So this is only going to happen once a day at the most. And the way we set this this file and this flag is when we just do our normal hour do LTE function, which sends IoT data over LTE. If it hasn't been able to connect, then it sets up that do LTE connect file, so it creates this file. If it had managed to connect, then it resets it, so it removes that file. So when it does its reboot once a day, it doesn't try and reconnect again if it's got a good connection going last time it tried. So now let's have a look at this in the real code. So let's see how that pseudocode was actually implemented. So I've added in some feature flags in here to help with testing, so things like skip LTE processing, skip Wi-Fi processing. But this one's an important one, do daily reboot. So this indicates whether we want to reboot the Pico processor every day. By default it's set to true. Then down here is the piece where it sets a flag for indicating that when we do come through here, this code the first time, we want to do and try and re-register the LTE connection, and it does that by detecting whether a do LTE connect file is present, and if it is, it sets this wait for LTE flag. Now this is used close to the end, so just before the event loop. Down here, it checks that flag, wait for LTE. If it's set to true, then it'll try and do the LTE connection. And this is the bit that does that re-registration up to 50 times. So it can take 2 or 3 hours to do, but it's only going to happen if it's lost its LTE connection, and only takes that long if it can't immediately re-register with LTE, and only does it once a day. And the piece within the main loop that I just showed you, this is what the actual code looks like. So down here, first bit of code is just decide if it's time to do a reboot. So using the clock, it decides if it's a specific time. So I set it for 6:20 AM GMT, which turns out to be about 1:20 AM my time at the moment in the east. If it is, then it does a machine reset, which reboots the Pico, gets it to drop through this code again, so that's where it does the reconnect if it needs to. And the other piece to look out for is if it gets to the stage where it's time to do an LTE transmit, it calls do LTE, and this is the part where in do LTE, if it fails, it'll go and create that file, but it doesn't in the actual do LTE routine, which is further up there. Okay, if we want to see where this code's working, the field I'm going to really look at first is this LTE connect count. So that tells me how many times it had to try and do the reconnects. Remember, it can do it up to 50 times. And let's go find a place where that's happened, where we can track the whole process. So down here you see first it's about 1 o'clock in the morning, and there's the kind of the last time it had a good normal connection, but it had to use Wi-Fi, so it indicates LTE connection wasn't working. We can tell that because no files went up by LTE. This is the LTE file count. So probably about 1:20, the Pico did a reboot, saw that that flag was set to say it needed to do a reconnect, and this column here where it tells you how many reconnects it had to go through tells you whether it connected again or not. So it had to go through the loop 7 times, so that's probably about 7 times 5, about 30 minutes to get a good LTE registration done again. And then after that it falls back to just the normal processing here. So at 2:07 it's connecting through LTE again. 3 o'clock, 4 o'clock, 5 o'clock, it's back to just connecting through LTE again. So we've got our LTE connection going again. So it looks like everything's working the way I'd expect. Next problem I had turned out to be due to the I2c interface, and what it looked like was this. So here you can see things are sort of running normally, and the uptime keeps increasing every hour. But as we go forward, this is where I first installed the new head unit, which had 2 more I2c devices on it, so the IO and the OLED interfaces. As soon as I did that, it started rebooting every time it came up, basically. Sometimes it'd stay up for a little while and then it'd reboot again. So it was really weird. It took me a while to work out what the problem is. You can see it started working again here, and then it started doing it again with the I2c interface. Now down in the main routine here, everything runs in the main loop, runs in the context of the main. So it has this wrapper around everything that's running in main loop, where if there's an exception, it writes the exception details out to a file called exception.txt. So when I was getting all these errors, I went out and had a look to see where the exceptions were coming from. So I was seeing this sort of pattern in the exception test, where it'd go into main loop, and then it'd fall over in the BME 688 section of the code, which is the environment sensor. That was working before I plugged in the actual extra I2c devices. So there's probably nothing wrong with that before, so it took me a while to work out what was happening, but it seems to be caused by voltage and also some of my code. I should have done more checking on whether that sensor was there before trying to talk to it, so it didn't actually have an exception. So one problem I was seeing was electrically, when I checked the voltages on the QWIIC interfaces, the 3.3 volt line seemed to go down. The voltage seemed to decrease, and that may be just because of the number of items I had on it. And so I now had 4 items on it. So the first thing I tried was for 2 of the I2c devices, instead of getting their 3.3 volts off the QWIIC QWIIC interface, I went and got it off the board's actual 3.3 volt interface. The next thing I did was in the code, check whether the I2c devices were present before trying to talk to them. So just when the main loop started up, I'd created the I2c interface. I scanned the interface to find all the addresses that are there, and then depending on whether a device that I expected to be there or the address of the device I expect to be there was there, I'd set a flag, and I wouldn't write out to that device or talk to that device unless the flag was set. Last thing I did was started having doubts about the BME 688. That's the one with the volatile organic compound sensor in it, which needs to heat up an element. So I was thinking maybe that's consuming too much current to work nicely with the other I2c devices. So I swapped it out with a BME 280. So that's almost the same, still gets temperature, humidity, air pressure, just doesn't get the VOC or volatile organic compound reading, which I wasn't really using in the end anyway. So I swapped that out, and that seemed to solve things mostly. And we can see things running a lot nicer here. So this is just a chart of the uptime seconds. So remember, it reboots daily or nightly. So we'll see here uptime seconds grow until we get to about 1:20 in the morning, and then it reboots and goes up again. But you can see those daily reboots are the only reboots that are happening now. So it looks like it might have solved my I2c problems. I'm not getting any reboots during the day because it can't talk to one of the sensors. So everything seems to be working fine now. This is like looking at the last 14 days. So I haven't taken the camper out for a while. So final test will be to try out the same thing when the camper's out on the road as well.